So for this video, we're going to go through some examples of applying the properties of an incenter. So for number one, I want to find FP. And so I am given that these are all the perpendicular lines, and I do know also that P is the incenter, so that means that these angles are congruent. And so I want to find the length of FP. Well, we know from our incenter theorem that all of these perpendicular lines are actually all congruent to each other since P is the incenter. So that means that DP is equal to PE, which is equal to FP. So that means that FP is equal to DP. Here we see that DP is equal to 4, so that means that FP is also equal to 4. Okay, number 2 says in the diagram below, PD is equal to 5x minus 1 and PE is equal to 2x plus 11. Find PF. So here I notice that I again have that P is the incenter, and I know that because it is where all of my angled bisectors intersect at. And I see that I have these perpendicular lines coming out to the sides from my incenter. And so we know from my incenter theorem that these blue lines are actually all congruent to each other, or in other words equal. So that means that PD is equal to PE. So I can find x that way, so I have 5x minus 1 is equal to 2x plus 11. Subtract 2x. And I get 3x minus 1 is equal to 11. So 3x is equal to 12, and then divide both sides by 3, and I get that x is equal to 4. Now, this question was asking me to find the length of PF. And so we have PD and PE. I want to find length of PF. Well, since PF is actually equal to DP and EP, I can plug in x into either one of these. I'm just going to go ahead and plug it in for PD. So I know that PF is equal to PD. And so I can plug in my x value 4 in for x here. So I have 5 times 4 minus 1. So I get that PF is equal to 19. And you can check your work by plugging in 5 into, or 4 into the other. So if I plug in 4 into here, I get 2 times 4, which is 8. 8 plus 11, which is also 19. And so that's a way that you can check your work. Okay, for this last one, it says in the diagram below, QM is equal to 3x plus 8, and QN is equal to 7x plus 2. Find QP. So here, they just took out one of those angle bisectors, but this is still where, Q is still the incenter here because I have these angle bisectors meeting at that point, and I have these perpendicular lines coming out to meet at Q. And we know from our incenter theorem that that means that QP is equal to QN, which is equal to QM. So I have that QM is equal to QN. So 3x plus 8 is equal to 7x plus 2. And I'll go ahead and solve. So subtract 3x. I get that 8 is equal to 4x plus 2. And then subtract 2 from both sides. And I get that 6 is equal to 4x. And then divide both sides by 4. And I get that 1.5 is equal to x. And then I want to find QP, and so remember, since QP is equal to QM and QN, you can plug it in for either. I'll go ahead and plug it in for QN this time. And so I have 7 times 1.5 plus 2. And so I get 10.5 plus 2. And so QP is equal to 12.5.